All right, let us do this question. It's a problem solving question, okay? Now basically here is we are given the diagram and we are also given about the information. So this information, it tells us everything of what is happening in that diagram, okay? But before we do that, let us read the statement together so that we can understand what is basically happening there without just looking at the pictures, okay? Now let us start. So here they say that a bullet of mass 2 grams traveling horizontally strikes a 1 kg wooden block which is at rest. Okay, the bullet emerges instantly on the opposite side of the block with a reduced velocity of 50 meters per second. The frictional force acting on the block is 1,96 newtons. The block is observed to travel 0,09 meters before stopping. Now, like I said, this information tells us on what is basically happening in the diagram. Okay, now let us unpack everything as we are being told in this information, or what is basically happening in the diagram. Okay, now remember, this is a bullet and this is a wooden block. Okay, this is before a bullet collides with a wooden block. Now here what is basically happening is, number one, the most important thing that I want you to take note of is the mass. Okay, remember here in physics we do not use grams but we use kilograms, meaning we're going to have to convert this mass of grams into kilograms. How are we going to convert that? We are going to divide 2 by 1000. If we divide 2 by 1000, therefore we now know the mass of the bullet. The mass of the bullet in this case will be equals to how much? 0,002 kilograms. Okay, the mass of the bullet is now equals to 0,002 grams, not 2 grams. Okay, now okay, what is happening is we're given the mass of the bullet and the mass of the wooden block. The mass of the wooden block in this case is equals to how much? Is equals to 1 kilograms. Okay, is equals to 1 kg. Okay, now initially these two objects are placed far apart from one another, whereby the bullet is traveling to strike the block. As the bullet travels to strike the block, after collision, what is basically happening? This is what is basically happening. The bullet will emerge on the opposite side of the block, and therefore now the bullet will have a reduced velocity. Meaning, initially, bullet had a certain velocity, but we do not know that. We do not know the magnitude of the initial velocity. That certain velocity of the bullet that initially started with, we do not have it. We do not know it. But now after collision, the very same bullet will emerge on opposite side of the block. But now the velocity of this bullet will now be reduced to 50 meters per second. Now, after the collision of the bullet and the wooden block, what is going to happen with the wooden block? The wooden block will change its position, meaning it will shift from this position to that position. These are the traces of the wooden block after wooden block collides with the bullet. Meaning our wooden block will move a displacement of 0,0 meters from where it was moved, meaning it will take a displacement of 0,09 meters. Okay, that's what is basically happening. And don't forget that there is also a frictional force acting on the bullet, so that frictional force will decelerate the wooden block to come at rest. Hence why from this position to that position is a point of rest to a point of rest. Okay, because there is a frictional force that opposes the motion of a moving object, so that frictional force will cause the wooden block to come at rest. Now we are also given the magnitude of that frictional force. In this case is equals to 1,9 newtons. Okay, and therefore now let us do calculate. Let us read the question together and see what does the question want from us. Okay, now the question, it says, calculate the magnitude of the initial velocity of the bullet without using energy principles. We can calculate the initial velocity of the bullet using energy principles, but this is without. Most definitely we are going to use the equation of motion, okay, because this is physics, mechanics. Okay, now to calculate the magnitude of the initial velocity of the bullet, meaning this is the velocity that we are looking for. We are looking for the velocity of the bullet before it strikes the block. Okay, that's what you're looking for. Now let us do the calculations. Okay, now how are we going to calculate that initial velocity, this initial velocity of the bullet? Now before we do that, like I said, we are given the mass of these two objects. Okay, now look, this is what is happening. The bullet, because it has its initial velocity, and we do not know, because that's what you are looking for, we do not know the magnitude of that initial velocity. This is what we know. We have the momentum. Okay, we have the momentum of the bullet initially. Now the momentum of the bullet initially is equals to what? Look, the momentum of the bullet initially is equals to the momentum of the bullet finally plus the momentum of the wooden block. Why do I say that? Now the momentum of the bullet is equals to the momentum of the bullet finally plus the momentum of the wooden block after collision. Now this is basically what is happening. There will be a transfer of momentum. Remember, I carried the wooden block, it was at rest, right? And the bullet, it was traveling horizontally to strike the wooden block. The moment the bullet strikes the wooden block, the very same bullet, it will transfer its momentum into the wooden block. That's why this scattered momentum, the momentum of the bullet itself finally, because due to decreased velocity of the bullet. Now remember, after bullet strikes the wooden block, the velocity got reduced to 50 meters per second, meaning this velocity got reduced because of collision, because of transfer of momentum, meaning the total momentum of the bullet initially, it was transferred into the wooden block. This is the momentum that was transferred, and this is the remaining momentum of the bullet after collision. Meaning if I come with, if let's say for example my momentum is 10 and we collide, my momentum now is reduced to 8, meaning I transferred 2 into another object so that that object can also move. So for the fact that that object is also moving after collision, it has absorbed my momentum and the remaining momentum to me, meaning it will also be reduced. Okay, now so how are we going to do that? Remember, because now we have the momentum of the bullet initially. How do we calculate the momentum? We use mass of the bullet multiplied by the initial velocity of that bullet is equals to, how do we calculate momentum of the bullet finally? Mass of the bullet multiplied by the velocity of the bullet finally, meaning which is after collision. And then how do we calculate the momentum of the wooden block? We're going to say mass multiplied by the velocity of the wooden block initially. Okay, now this is what we are looking for. We are looking for VBI, the initial velocity of the bullet. That's what we are looking for. Okay, we have the mass for the bullet. Yes, we have mass of the bullet, which was converted to be 0.002 kilograms. Same applies here. We have the mass for the bullet. We have the final velocity of the bullet after collision. Yes, it was reduced. Remember, the velocity of the bullet after collision, it was reduced to 50 meters per second. We have the mass for bullet. And in this side, let's talk about the momentum of the wooden block. Do we have the mass for the wooden block? Yes, we have it, but the problem is we do not have the velocity of the wooden block. In this case, we're going to have to calculate the velocity of the wooden block so that we can add these two momentums. Now we have the momentum of the bullet. Now we can determine the initial velocity of the bullet. Now let us start first by determining the velocity of the wooden block. But before we do that, let's go back to our diagram. Because we are looking for the velocity of the wooden block, we're going to have to focus on wooden block. Okay, remember, in this case, wooden block changed position from this point to that point, and it has traveled a displacement of 0.09 meters. And remember, on top of that, there was a kinetic frictional force which opposed the motion of this wooden block to move from this position to that position. Hence why this wooden block came at rest, because of that kinetic frictional force. Meaning we are going to use Newton's second law first to determine the acceleration of this wooden block from this position to that position. How are we going to use Newton's second law of motion? We are going to say F net is equals to mass multiplied by acceleration. Now, what is F net? F net is the sum of all the forces that are acting on our wooden block, because we are focusing on the wooden block. Now, in this case, because our wooden block came to rest, what caused the wooden block to come into rest is kinetic frictional force. Now, in this case, our F net in this case will be kinetic frictional force, but now in opposite direction to the motion of a moving object. Remember, here in physics, we choose to the right to be positive. You choose your own direction, it's up to you, but we choose to the right to be positive and to the left to be negative. And the kinetic frictional force, as the object is moving to the right, that means kinetic frictional force is moving to the left. So F net is given by negative Fk is equals to, for kinetic frictional force, mass of an object multiplied by acceleration of the object. Now, what is the kinetic frictional force acting on wooden block? It was given to be 1,96 newtons, okay? Meaning it is given to be, here we're going to have negative 1,96 newtons is equals to, what is the mass of the wooden block? Is equals to 1 kilograms. Do not forget that the mass of the wooden block is 1 kilograms, okay? It's 1 kilograms multiplied by the acceleration. Now, what is the magnitude of the acceleration? Acceleration is equals to negative 1,96 meters per second squared, meaning acceleration is equals to 1,96 meters per second squared to the left, or you can just simply write to the opposite direction. This is a deceleration because our object was moving to the right. But in this case, we say to the right is positive. Any vector quantity that will be moving to the right will be positive. That means any vector quantity that will be moving to the left is negative. Now, for the fact that our object is moving to the right and our acceleration is into the left, that's deceleration basically, okay, because of kinetic frictional force. Now, we know that what? We know the magnitude of the acceleration of the wooden block from where it started until it took a displacement of 0,09 meters. Now we are going to use this acceleration to determine the initial velocity of the wooden block to that point. What was the initial velocity that took this wooden block at this position to that point whereby it traveled for 0,09? Now we are going to use the equation of motions. We have Vf squared is equals to Vi squared plus 2a multiplied by change in x, because this is a horizontal motion. Now, what is Vf squared? Remember, we want velocity at final point. This is the initial point of the wooden block, the final point of the wooden block. The initial velocity of the wooden block, final velocity of the wooden block at this position, it was 0, okay? We have 0 to the power of 2 is equals to initial velocity of the wooden block. It's basically what we are looking for, because we do not know what was the initial velocity of the wooden block. Plus 2 multiplied by negative 1,96 multiplied by our displacement is 0,09 meters, meaning it took 0,09 meters from this position to that position, okay? Now, here we have 0 is equals to Vi squared, and therefore, let me punch this on a calculator. 2 multiplied by negative 1,96 multiplied by 0,09. Here we have negative 35. Sorry, we have negative 0,3528. Okay. Therefore, let us transpose this number to the other side of the equation, meaning Vi squared is equals to positive 0,3528, and therefore root sign on both sides. Our initial velocity in this case will be equals to 0,59 meters per second to the right. Okay, meaning the initial velocity that took wooden block from this position to that position, it was found with our calculations to be 0,59 0.59 meters per second. Okay, that will be our initial velocity. But remember, yes, we were looking for that initial velocity so that we can get the momentum of the wooden block. Now we go back to our formula. This formula, we are going to say mass of the block in this case is equals to 0.002 kilograms multiplied by velocity of the block initially is equals to mass of the bullet. This was 0.002 kilograms, and then what is the mass? It was 50. Velocity of the bullet finally it was reduced to 50 meters per second, plus mass of the wooden block it was 1 multiplied by the velocity of the wooden block. Initially it was 0.59, the one that we have just calculated above, and therefore here we have 0.002 VBI is equals to, let us add this on our calculator, this multiplied by 1 plus 0.02 times 50, and therefore we get 0.693 blah 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 blah, and therefore we divide both sides by 0.002, and therefore our initial velocity of the block will be 346,98 meters per second to the right. Therefore that will be the initial velocity of the bullet. Thank you for watching.